Do you like cheese? Mac and cheese specifically? Of course you do. It's noodly carbs soaked in cheesy carbs, and if you're feeling adventurous, you can even sprinkle some breadcrumby carbs on top. But have you ever tried to actually make mac and cheese, like from scratch? If you have, then you might realize it's actually pretty complex for a dish that's named with just only 2 ingredients. Just watch any of the plethora of fancy YouTube chefs' recipes that require butter, flour, milk, and different types of cheeses, and just an ungodly amount of freshly ground black pepper. And if you've gone through the effort of following along with these recipes, what you're greeted with is something that looks and tastes more milky than cheesy exactly. And if you mess up the recipe, what you get is something that's watery and oily and grainy at the same time. So what gives? Hi, I'm Kevin, technically a doctor, definitely a mac and cheese enthusiast, and unfortunately someone who likes to find complex answers to very simple questions, such as, why is it so hard to make a good mac and cheese? And why might lemons be a solution? It's simply science. But before we can talk about the solution, we need to first identify the problem. And our options are pretty simple in this case because we only have 2 choices, mac or cheese. Exactly. Cheese, you are the problem. Macaroni, you are perfect, and I love you. So yes, cheese is the problem. But have you ever wondered what cheese is exactly? If you thought that cheese was just dried out milk, then you're exactly like me. Which means you are wrong, and I hate you. But you're not entirely wrong. I will probably cover cheese making in a separate video because I find it super interesting. God, saying that out loud makes me feel super nerdy. But for now, please settle for this quick summary. Milk is actually pretty complex, containing water, oils, sugars, proteins, and vitamins. Now, as we all know, water and oil can't stand being around one another like a married couple that have long since fallen out of love. And what keeps these two together? The kids, or in milk's case, casein, which wraps around the oil and allows it to be dissolved in the water in what we call casein micelles. So to make cheese, what we do is we add something to interfere with these micelles' ability to stay in solution, which causes them to slowly fall out. And with the metaphorical children sent off to college, the water can be separated from the oils, which gets to keep the casein and solids in the divorce. We call these solids cheese, and like any single parent after a divorce, the more time that passes, the more intense the cheese becomes. Flavors-wise, that is. However, as the cheese ages, it also loses moisture, which causes the micelles to stick together and become bonded because of calcium ions. So when you heat up the cheese, you cause these proteins to open up, releasing the oil and causing it to separate. This also causes the remaining proteins to become burnt. And so this is the major dilemma with making a good cheese sauce. How do you get these proteins and oils to dissolve in the water without breaking down? How do we pull Lindsay Lohan and Parent Trap our cheese solids and liquid into getting back together? And sure would be great if there were some magical powder that you could add to help solve this problem, he says sarcastically, saying up his next point. And that leads us to emulsifying salts, also called emulsifiers, but more about that later. Now, this is kind of where things get a little tricky. See, there are tons of YouTubers talking about how wonderful these salts can be and can turn the hardiest of Goudas into a Velveeta-like goop. Adam Ragusea actually has a wonderful video talking about how you can use Trisodium citrate, probably the most common emulsifying salt, to make a really good mac and cheese. And his recipe directly inspired this video, albeit 4 years later. But for every YouTuber talking about how wonderful emulsifying salts can be, there's another one talking about how terrible they are for you and that you should avoid them at all costs, and especially avoid cheeses that come with emulsifying salts in them, also known as
processed cheese.
A little dramatic, but I get it. See, it's kind of suspicious that Kraft Singles, the poster child of processed cheese, legally can't be called cheese and instead must be called cheese product because it contains less than 51% real cheese, whatever that means. And I get that you might not want to take an unknown chemical and add it to your food, no matter how much other YouTubers are saying you should. And it sure would be great if there was some way to make emulsifying salts from something natural that you're familiar with. Lemons. We're talking about lemons. Obviously, we're talking about lemons. See, trisodium citrate is just the basic form of citric acid. The sour stuff you find in sour food like Warheads, Sour Patch Kids, or, I guess fruit. Specifically citric fruit, such as oranges, limes, or in our case, lemons. So yes, the goal is to take lemons, squeeze out their juice, and convert the citric acid to trisodium citrate and see if we can dissolve mac and cheese with it. And I generally have no idea if this will work, right? For example, Nile Red has a video talking about how you can isolate citric acid from lemons, because of course he does. But in it, he uses pretty dangerous chemicals that I definitely don't want to try to eat afterwards. I haven't seen anyone try to use common and edible ingredients to convert the citric acid and lemon juice into trisodium citrate and use that to make a cheese sauce for mac and cheese. Hey, Future Kevin here. So technically that wasn't a lie. At the time I hadn't seen any videos, and still there are no YouTube videos, but Ambergucia did make a YouTube short going over making a cheese sauce using lemons and baking soda. But his video is only a minute long. It doesn't really go into the science, so hopefully you still find this interesting, but I figured I should at least mention it. Anyway, that's it. Back to the video. So let's give it a shot. Great, so we start by juicing several lemons. Fun fact, you can get more juice out if you roll and squeeze them first. And then we go and cut, followed by squeeze, 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 and pour, pour, pour. This leaves us with around 135 milliliters of lemon juice at the end. I found a source that gave an estimate of the amount of citric acid in lemon juice, and so from that I was able to calculate that we should have around 6.57 grams of citric acid in our lemon juice. Once we have that, we just need to add a base to the mixture to convert the citric acid to sodium citrate. I chose to use baking soda because I assume pretty much every baker has some, and I prefer to not use drain cleaner in my food. I'm quirky like that. I tracked the reaction using pH paper, which gave us a starting pH of around 3, which makes sense. I had a stir bar to help with stirring. And then just kept slowly adding baking soda to the mixture until the pH ran around 8. This took quite a while and released a fair amount of gas. This wasn't super surprising. This is the same thing that happens with a baking soda volcano. It just comes from the baking soda. It has nothing to do with the lemons. Now, baking soda is pretty weak, and so this reaction is going to take a fair amount of time. That's because citric acid has 3 different protons that need to be removed to give you the trisodium citrate. Eventually, as you can see, I had to transfer to a bigger beaker because the foam was just getting too intense. But as you carry out the reaction and the baking soda stops reacting with as much citric acid, the foam should eventually die down, and that's a good sign that you're close to about there. Well, eventually the pH reads about 8, meaning that the reaction at this point is mostly complete. Calculated I should have needed around 8.618 grams of baking soda to neutralize all the citric acid, but I actually ended up using a total of 57 grams, which is about 6 times the theoretical. And as you can see, there is some baking soda left at the bottom of the jar, meaning I just added way more than necessary. I'm not particularly concerned because the next step is filtering, which means that any solid baking soda will just be removed as well as any leftover solids from the lemon. I did this just by putting a coffee filter in this little silicone funnel and just pouring the solution over it. It seems like this might take a bit. And so while we wait for that, I want to talk to you about how emulsifying salts work. See, remember when I said, and that leads us to emulsifying salts, also called emulsifiers, but more about that later. Well, later is now. See, while trisodium citrate does help to make an emulsion, it is not an emulsifier. Nitpicky, I know, but this is important because literally every other YouTuber gets this wrong. See, an emulsifier is something that gets 2 liquids like water and oil to go together well. Soap is a great example. Trisodium citrate doesn't do this. Try washing your hands with trisodium citrate. I dare you. Won't do a thing. So if trisodium citrate isn't an emulsifier, what is it? What does it do? from what I can find, it seems like trisodium citrate is just a really good calcium sponge, which takes some of the calcium ions used to tie the casein protein together. And with the calcium ions gone, you can dissolve the casein micelles back into liquid to make a delicious cheese sauce. Going back to the reaction, you can see that after a couple hours of filtering, we are left with about 90 milliliters of solution. This should be enough for about one shot at the recipe. Okay, so I started with the 90 milliliters of sodium citrate solution and added about 120 milliliters of reserve pasta water from cooking the 224 grams of macaroni noodles, which obviously occurred off screen per package instructions that we all follow precisely, as is custom. I then added a stir bar and heated the liquid to be about 55 degrees C or 131 Fahrenheit. Also off screen, I shredded 254 grams or a little more than half a pound of medium sharp cheddar cheese. And then I began to slowly add the cheese in small increments, making sure to wait until the cheese was fully dissolved before adding more. At first, it didn't seem like the cheese was actually going to dissolve, and I had a mini panic attack. But after I prayed to whatever God you believe in, I noticed that the cheese actually was starting to dissolve, indicating that the sodium citrate was actually doing its job, which was pretty cool. However, I didn't want to overwhelm the sauce, so I still had to add the cheese in very slow increments. So this took quite a while to get all of it to dissolve. To make matters worse, after at some point, the sauce becomes too thick for the stir bar to really do anything. So I ended up pretty much just turning off the stirring and using a stir rod to try to mix the rest of it until it was a pretty uniform consistency and all the cheese had finally melted. The next step was to take the noodles I had cooked separately and just pour the sauce over them directly. At first, it seemed like there was maybe too much cheese sauce, but once it got into every nook and cranny of the noodles and the sauce was able to evaporate quite a bit, it became an actually really nice uniform cheese sauce. I mean, look at that. That looks perfect. It looks exactly what Kraft would put on the back of their box. But looks aside, I guess the only thing left to do is the taste. Is it any good? It's kind of weird to think about this as just being a block of cheese somehow, and lemons, but yeah, let's try it. There's kind of a soapiness to it. Definitely need some salt, maybe some pepper. I think I could really, but overall, like, I kind of was half afraid this would just separate out and not work at all, and then I delete all of this. But no, this worked pretty dang well. It's almost buttery. I don't quite understand how, because there's no butter. It's, again, just lemon, water, cheese. But it's actually pretty good. Damn, I did it. Yeah, this is. I'm definitely going to eat all of this, or / share some with my wife. But yeah, this is definitely a success. So yes, you can in fact use the lemon juice to stop cheese from splitting. And if you want to try this at home, I include the recipe in the description below. But if you don't want to go through the effort of doing this every time you want mac and cheese, I don't blame you. You can just buy some sodium citrate online and use that, or easier still, you can just melt some processed cheese and add some real cheese to that. The entire point of this video is to show that not all food additives are evil. Many of them are naturally occurring compounds that you're likely to run into anyway in your normal diet. I think it's common to run into things in our everyday lives that we realize we have no idea how they actually work. And when we do realize this, they can be intimidating or even scary. But if you take the time to understand the science behind them, you realize they're actually pretty simple. Anyway, that's the video. I think I want to make a lot more of these. There's tons of things that we use in our everyday lives that have some really interesting science behind it, but you just might not realize it. And if you have any topics you think could make a good video, leave a comment down below. And be sure to like the video if you liked it and share with anyone you think might like it too. Anyway, that's all I have. So thank you so much for watching.